I want to start with a real story that will set the stage. And the location is the NEOPOG, which is a consortium of Department of Transportation officials, contractors, academia, binder suppliers, additive suppliers, a technical committee that's organized a few times in a year. And the Department of Transportation officials from one state were particularly anguished because of recent rash of payment failures. So they were pretty much accusatory in their tone, with the binder suppliers telling them basically, "What have you put in our binder?" And the binder suppliers, being somewhat defensive, said, "Nothing that you don't know about, and by the way, it meets specs." So you see, the pavement failures and the quality issues that you're talking about today, or that we are all talking about today, are not new. They have been across different continents, across different time zones, and what you're facing is not unique. So, what is this due to? What is the changing landscape of bitumen look like? For much of the last century, refiners used local crudes that didn't change very much. So there was a great deal of stability in the output bitumen that was produced. That's not true anymore. The person who controls the crude slate, and slate is simply a diet of crudes that are fed into the refinery. The person who is controlling that is not the plant manager, is not the operations manager. It's some logistics person, perhaps sitting in a corporate high headquarters, buying whatever crudes he can from different sources to create this crude slate. And his key criteria, that is the potential output of gasoline, petrol, jet fuel, and other top end products from the barrel. And so the resultant bitumen will vary in price, will vary in source, and vary in quality, perhaps even from run to run. Today, it's quite possible that the refinery operator or the terminal operator has already added some extenders, some additives before the contractor or the binder supplier or the PMB supplier or the emulsion supplier has even seen it. Today, in response to a range of different environmental concerns, there is a drive to lower the carbon content, and that has led to some quality issues. Um, the quality of bitumen today may also be influenced by a host of different technologies that didn't quite exist in the last century. Things like cat cracking, syncrudes, even synbit, block running, and a few other things. So bitumen today is not provided abundantly, is not necessarily a global product, and is increasingly being defined by economics outside our control. So, what is this new world that we find ourselves in? Many of these elements are familiar to you, so I'll go over a couple of them. But basically, if you give a supplier a spec, he will meet it. That may or may not be what you want. So it is incumbent upon each one of us to define what performance means to us in terms of conditions of traffic, in terms of climate, in terms of expectations for a lifetime. You see, the very PG specs that were put together at the turn of the last century, the several state departments are modifying it. Now you have PG plus with massacre. You have PG plus plus with perhaps some mixed level testing also thrown in terms of fracture toughness, in terms of moisture resistance. Your grandfather probably defined a pen softening point spec, and that served him well. It even served his son well, perhaps. But that kind of permanence is now disappearing, and there's an ongoing search to define better. And newer analytical techniques have also helped what is needed for performance. Another point that needs to be mentioned is several regions, several countries become completely or partially dependent on import bitumen. Several facilities have closed. Certainly, new ones have come up, but many have closed. And South Africa is perhaps just one example of this. You will have to learn to live with imported barges every 1, 2, 3, 4 weeks, and some advanced recon may now become a key tool in your toolbox. High RA mixes are also becoming more widespread around the world. This has an impact on demand, reliability, and that has an effect on reliability of supply and perhaps even quality. So what's happening here? On the left-hand side, you can see a number of questions. This is probably common locker room, water cooler type, or perhaps even key questions that are being asked in quality rooms and perhaps even boardrooms. To understand this, you really have to look at a story of three parts, which is what has happened to the crudes, what has happened to the procurement practices and how have they changed, and finally, what has happened in the refining process. All of these have an impact on quality and therefore impact on your business. The sourcing of crudes, I've already alluded to, defined completely by production of light ends and economics of that particular barrel. And this leads to a slate of disparate crudes, introduction of this vast array of global sources of crude, and perhaps even unconventional crudes such as syn crudes. Oil refining today is a global business. It always was, but in a different sense. Today, the crude may be produced in China, but refined in Rotterdam, or produced in Canada and refined in Brazil. Very large crude carriers and supermax carriers plying the oceans have made this feasible and made this economical. Nitisang put up that chart of probably 150 odd refineries producing bitumen pretty much around the globe. It would not be uncommon for several of these to have found their way into several different continents, and that leads to a complexity of situation. But bottom line, procurement practices have led to the simple fact that frequently the decision maker for these crude slates that impacts your bitumen is a computer jock with a set of equations and a moving price ticker. How did we get here? This is part two. This is a crude depiction of some of the changes in the crude oil process. Pardon the pun. I'll provide some of the backdrop and highlight some of these. In the 80s, it was quite common for refineries to either operate on heavy crudes or light crudes. Heavy crudes, heavy in bitumen content, heavy in solids content, and light crudes exactly the opposite. The appearance of crack spreads used to cause great dislocations and perhaps jeopardize the economic viabilities of several companies. So today, refiners can operate with either just by the flip of a switch. In fact, they operate with multiple crude slates, input crudes, called a slate of crudes, that consists of elements from both or either. Cokers, predominantly introduced maybe late 90s, have now come to, and light end harvesting. This is simply the practice of getting more and more light ends from that barrel of crude, and therefore that has changed what's left behind in the bitumen and impacted the bitumen characteristics. As has the practice of using synthetic crudes, shale oil crudes. Some of these are really, really very, and really they've been created to run very efficiently in refining operations, but some of them do produce poor quality, documentedly produce poor quality bitumens. As always, economics has intertwined with refinery production operations. Price shocks and collapses have triggered the search for cheaper and cheaper crude slates. Today, $60 or $70 barrel of oil is often regarded as the floor. Formerly, it was the ceiling. People talk about $100, $150 barrel of oil. And when we get there, this will trigger a new round of quality manipulations. Finally, I'll spend a moment or two on MARPOL, marine pollution laws. At the turn of the century, it was discovered that sea life was being affected. This led to a search for the causes, ultimately traced to the sulfur content in bunker fuels. That's the fuel that the ships used to ply the oceans. And so starting 2020, there were strict reductions in the amount of sulfur, often by 100-fold in the bunker fuel component. Well, guess what? That sulfur has to find its place somewhere. Some of it trickles down into the bitumen with adverse consequences. The thing I want to emphasize here is that there has been no step change in all of this. There has been no step change in quality. It has been an evolving process in terms of a confluence of a lot of different influences on the refining crude oil operations. Just as crudes have been changing, so too has refining. And I'll highlight a few of them. I'll start with the basic concept that today in the Western world, there are fewer refineries in operation. Certainly, there has been an increase in certain parts of the world, notably Asia, but there has been a constriction in the number of refineries that are being in operation, or perhaps even today being discontinued from production. Then I mentioned the whole host of new crudes. Crude is exactly what the name implies. Tar sands that are mined in, let's say, the Orinoco Belt in Turkey, in the Athabasca region of Canada, etc. They are sent to an upgrader, lightly refined to produce something that looks, resembles, feels, tastes like crude. These are piped from, let's say, from Canada to the Midwest, Chicago, find their way perhaps all the way into the Louisiana terminal, get loaded onto barges, and these synthetic crudes are now transported pretty much across the globe. The rise of supermaxes and very large crude carriers has certainly implemented or helped some of this, and that finds its way to a refinery near you. These synthetic crudes and shale is the oil derived from a very tight rock formation. Newer technology has allowed us to extract these oils. They really are terrific for refinery operations, very finely tuned refinery operations. Some of them do not lead to good quality bitumen. Synbits. Synthetic bitumen is exactly as the name implied. The process of upgrading in an upgrader produces a sludge, which is then again lightly refined to produce a bitumen-like component, which is often blended with bitumens and sold off. Block running. Block running is a practice typically adopted by refineries where they run one particular slate, let's say a very heavy directional slate, produce a lot of bitumen, and then switch off, run light crudes for a period of time. And the resultant bitumen from that is now mixed with the bitumen that was produced. So this is kind of block running. And after the block running process, the refinery or the terminal operator will just blend these to be able to get to a defined spec. Topping refinery, let me spend a moment on this. Perhaps it's familiar to some of you, perhaps not. Some refineries could only operate, and this goes in the past, some refineries could only operate on certain types of crudes or perhaps only produce light ends. So they used to get as much of the petrol, of the gasoline, of the jet fuel, the naphtha, etc., out of it, and then send the rest of the fluids to other refineries. One of them is a topping refinery. And the sole output, 90+% of the output of that topping refinery was bitumen. And therefore, the runner, the person who ran this topping refinery, was very acutely aware of the needs of his customers, the needs of the contractors, the need of the roofing operations, etc., and produced a spec that was very largely in sync with that. Well, economics has completely upended this business, and the topping refinery has ceased to exist, and that removes a very valuable source of highly defined quality material into the operations. Why is all of this important? Ladies and gentlemen, I'm going to lay out some corollaries for you. And I'd like to say to you, each one of you to say to yourself at the end of my sentence, while still meeting functional specifications. So let's play this game. Different crude oils, and different speakers today have alluded to this. Different crude oils yield different grades of bitumen, while still meeting functional specifications. Blending of different crude oils or blending of different bitumens creates different functional characteristics while still meeting specifications. So you see, there is a number of factors that can be changed at your bitumen level while still meeting what it is that you have nominally defined as a spec. And this is what people are discovering. Something may meet spec for softening point or PG grade, but may not be suitable for PMB, polymer modifieds, in terms of stability, in terms of compatibility with bitumen. It may not meet emulsion producers' requirements. So there is that element that has to be considered today. The other thing that I do want to touch upon briefly is there is a large number of new players. There always has been a large number of new players entering this business. What is new here today is the rise of integrated traders. These are people who were initially started off as price speculators, either in crude or in bitumen. They have moved upstream and downstream, and today they are supplying, and you probably know good examples of these. They are supplying bitumen pretty much across Europe, across North America, and indeed in some portions of Asia and Australia as well. But basically, these were attracted by price speculation. High prices will always invite extenders, and changing quality will always attract suppliers of additives, suppliers of modifiers, etc. Sustainability trends are also, and we'll talk about this in a moment. Sustainability trends have also given to a new layer, have given the characteristics of bitumen and the quality of bitumen a new layer of instability.
2-minute warning, sir.
Yes. Can you hear
2
me?
minutes.
So there have been quite a few impact of these changes. I'll highlight a few of them very briefly. There has been astonishing rise in the number and scope of modifiers now used in this industry. I'll just point out some of these. Most of you are familiar with them. The ones in italics are the ones that are perhaps more recent. Another consequence is the rise of PMBs, perhaps even in overspecifications. They have a history of documented performance, and so there's perhaps an increase, and some of this may have been driven by traffic conditions, by climatic conditions, etc. Another impact has been the rise of what's known as a managed network. And in these, you have people in many countries who build, operate, own, and toll, and they have very specific manufacturing specifications in terms of duration in which the pavement needs to be reworked. They perhaps are not as sensitive to the needs of quality that some of the longer term pavement durability people need in terms of 5 years, 10 years, 15 years, and so on and so forth. So I've outlined quite a few changes and quite a few upsets. So the question is the situation hopeless? Not quite so. Quite a few steps are being taken. Let me start with the notion that it is possible to take a substandard bitumen and still create a quality mix. And this has been largely the purview of additive and modifiers and extenders. With the usual caveats, they don't always work. They don't always work across different bitumens. They're not consistent. And dosing, the level of usage of some of these materials is quite sensitive to various issues such as durability and phase separation, etc. The thing I want to highlight is perhaps this audience should start considering mix level targeted specifications, not just binder only parameters. This notion increasingly that binder level properties can consistently predict or performance related characteristics may not be the case. Blending, I mentioned blending as a cause of variability. Several participants, industry participants, are actually using this, mixing two or more non-standard bitumens to be able to produce an on-target material. The other thing that must change is obviously some of the conversations and the attitudes must change. I'll mention one thing here on the slide that I think probably several speakers have spoken to this, and I think the notion that chemistry can be defined, or even that quality can be defined in terms of asphaltenes and maltenes, and perhaps a peak in an FTIR curve. That's probably going to go away in a little bit. And here's the reason why. It's not that it doesn't have scientific meaning or is germane. It's that your supplier cannot measure it. He cannot modify it. He cannot do anything with it. And he is more reliant on physical property characteristics, rheology characteristics, and so on and so forth. I think I've already mentioned this. Adding more is not always better. There is a feeling in this industry, if 5% work, 10% will be fantastic, and 25% will be absolutely fabulous. With some of these new additives, that's not quite the case. And finally, performance metrics need to be considered in terms of both incorporating mix level specifications as well as binder level specifications. I hope I've given you a good insight into some of these changes. The only thing that I'll mention on this slide is environmental health and safety regulations. These are continuing to evolve, particularly environmental issues. The drive towards net zero is now beginning to spur the use of bio-based binders, not just 2, 3, 4% biomaterials in your binder, but 10, 20%. And the long-term implications of this are largely unknown.